All right, this is going to be the star review that we're going to do for the Algebra 1 test. Again, we've got 2 full weeks. So this week is English 1 and English 2. Next week is Biology and U.S. History. And then the third week is when we're going to take this Algebra 1 test. So I'm going to go through what this looks like, but remember we're on A-B days. So absolutely anytime I'm in class with you, you can work on this. And then on those B days when we have that study hall, you are welcome to work on this. And then any other time, especially during STAR test, if you're in class and the teacher is not there, you are welcome to work on this. So there's 5 sections, I think. There's 5 sections to it. It is all in this packet right here. So this is everything that we're going to do. We're going to start on our first one. We're going to talk about rate of change and solving for y. But there's rate of change, solving for y. There's linear functions. There's quadratics. There's an exponents with domain and range. And then we have exponential functions. And then there's going to be one page, which is really, it's in here just for for you to look over. So it's just kind of some keywords, some things to think about when we're testing. And then there's just some practice STAR questions at the back. And so as we go through this whole thing, I'm going to work out some of the problems with you, and then I'm going to give you some time to go in and kind of work through the rest of them. And then I will post the answers in there so that you can go in and check your work and kind of see what you did, see how you did, see what you need to work on. So we're going to start today on the first section. Right here in the front of your packet is the reference material for Algebra 1. These are the formulas that are made available to you. We may or may not use all of them, but they are here, and periodically as we're working through things, we will reference back to them. But they're here if you need them. Also, if you are assigned any supplemental aids, I will be talking to you about those, and I will get those to you as you're going through this if you want to use them. Guys, if you don't use them, just tell me you don't use them, and that's fine. But if you're allowed to use them, that's what they're there for. So when we start this first one, see if I can get this folded over. We are going to start by talking about rate of change. This is really linear functions, but rate of change, which is slope, right? Rate of change, we're going to reference that as the slope of the line. We're also going to talk about that as rise over run. We're going to see that a lot. If we're looking at the equation, that m right there, that is our rate of change. That is our slope. And back when we talked about slope, we kind of had 4 ways we talked about slope. And it's kind of intuitive if you think about it. When we read a book, if I ask you to read this sentence, we read from left to right. So we read slope from left to right all the time. So if you look at this one, as I'm moving this way across the graph, left to right, that is going up. And just in general, we think of up as a positive, so that is a positive slope. When that line is going down, we think of that as negative. That's a negative slope. Horizontal and vertical, right? Horizontal means sideways like this. That has a 0 slope, because remember what we're saying is rise over run. So how far up and down is this going? Over how far is it running? How far is it going sideways? And this could be a 3 or a 9 or a 4 or whatever you want to put in there, but 0 over 3 is 0. For a vertical, it's going to be the opposite. And I cannot divide by 0. If you don't believe me, go into Desmos, go into the calculator, something like that, try to divide by 0. It is undefined. It's not 0. It's not some other number. It is undefined. Okay? So if I get a line that's perfectly straight up and down and they ask me for the slope, it's undefined. All right. When we are looking at graphs, right, we said this is rise over run. How far up and down does it go? And how far sideways does it go? So if I'm given a graph The first thing I want to do is, the way they reference it is these perfect points. What that means is I want to find points where it goes exactly through the crosshairs of the graph. So if I tried to pick this point right here, it's halfway in between those. It becomes very hard to count. So you want to pick something where it crosses through the crosshairs. So if I look, this point right here crosses through the crosshairs. That is exactly on my graph. And then as I follow it, I've got another one right there. I've got another one right there. I've got another one right here. And it does not matter which two of those you pick. Let's pick a couple that are farther apart. So I'm going to pick those 2 points, and I'm going to count rise. Oh, let me scooch back up. I'm going to count rise and run. How far does it go up? So this one, if I'm going, remember, we're always reading from left to right. So I'm going to rise 2 units, and I'm going to run 1, 2, 3, 4 units. So with everything that we do, if we make a fraction, we can simplify that. Both of those are divisible by 2. So my slope is 1/2. And if you think about it, what it means is when I rise 1, I run 2. I'm back on my graph. If I pick any other point here, and I rise 1 and run 2, I am back on my graph. That's what that slope does to me. This little note right here says, if I count my slope, if I count my slope and I said, hey, I'm going up 3 and over 1, well, technically that's 3. When we reference it as slope, we're going to call it 3 over 1 because I want to make sure I understand that I'm moving over 1. So that's all that little note there says, okay? The next thing that you want to make sure you are paying attention to is the axes will not always go by ones. So I am not just counting 1 box by 1 box, okay? What I have to do, and this one's kind of hard to see, I don't know why they made it this small. We're going to call these 60 each. Well, we'll call it 60 each, 180 and then 240. I don't think that's what it is, but that's what we're going to do. And then on the bottom, these boxes are by 2s. Okay, so when we count this, yes, when I look at my box, I'm going up 1 box and over 1 box. But here on the side, I'm going up 60 units of whatever this is, and then I'm running 2 units. So you have to make sure you are watching that. And then we're going to divide that, right? So 60 divided by 2 is 30. And what we said right up here, though, is if it's a whole number, I'm just going to put it over 1 because that means I'm rising 30 and running 1. So don't just count the boxes. Make sure you look at the axes and how they're labeled. If they're just 1 and 1, or if it's not labeled at all, then we can assume it's 1 and 1. But most of the time, it's going to be, make sure you check the axes to see what those are, okay? When I have a table, I'm doing the same thing. So if you think about it, I could take these numbers and I could plot -6 and -2. And I could plot 15 and 33. And I could count how far that is between them. But I don't really want to do that. I don't want to have to count from -6 to -2 and from 15 to 33. I don't want to have to count those. So what I can do, what we have, is we have this formula that says y2 minus y1 over x2 minus x1. It basically means subtract the y values, subtract the x values, and put the y's over the x. Because I'm going to find the change in y over the change in x. So if I have these two from this table right here, I have -6 and 33, and I have -2 and 15. It does not matter which one of these you call 2 and which one you call 1. It does not matter. What I'm going to do is I'm going to subtract. So if I take 33 minus 15, the only thing I have to make sure I do, if I do this one first, then I need to do this one first, -6 minus -2. So if I start with the 33 on the y, I have to start with the -6 on the x. Don't switch them. And if I do this, if you go in the same order, it doesn't matter which one you pick, you're going to get the correct answer. 33 minus 15 is 18. And this is really -6 plus 2, so this is -4. 4 doesn't nicely go into 18, so we're just going to divide top and bottom by 2. So the slope for this we're going to call -9/2. And the only thing is, it doesn't, if I subtracted the other way, if I did 15 minus 33 and -2 minus -6, I would get -18 and +4. But that, as long as I have a negative, then this is a negative slope, which means it's going down. And so that's my slope right there. So just keep them straight. Make sure you know which one is which one. And they do give you the slope formula. y2 minus y1 over x2 minus x1. Subtract the y's, subtract the x's, put the y's over the x's. So that is on your formula chart. All right. So this is kind of a sample star problem. It shows the relationship between the balance of a student's savings account and the number of weeks they've been saving. So at 0 weeks, they have $32. At 1 week, $39. At 3 weeks, $53, okay? Based on the table, what is the rate of change of the balance of the savings, okay? I want you to notice something. This changes by 1, that by 2, that by 3, that by 4, that by 5. Doesn't really matter, but keep that in mind because I cannot look and go, oh, this is 1, so I'm just going to subtract these 2 and that's my answer. It's not. So what I have to do is pick 2 of these. And again, it doesn't matter which 2 we pick. Pick 2 that are going to be easy to work with, right? If I pick these 2, I'm going to subtract the y's and subtract the x's. So I get 39 minus 32 over 1 minus 0. I did the 39 and the 1 first, so I get 7 over 1. If I pick this one over here, I have 88 minus 74 over, and I have 8 minus 6. So that means I have, that's not a 4, that's a 2. So keep an eye on that because they may change. So 74 minus 88 is 14. 8 minus 6 is 2. Well, 14 over 2, both of those are divisible by 1. So I should get exactly the same answer every time. It shouldn't matter which 2 points you pick. I could pick this point and this point. That means I'm dividing by 13, but I should get the same answer. I should get 7 over 1. All right. So we're going to look at these real quick, and then I think it's going to be some practice problems. So this is if we're solving for y, right? I'm given this other equation, but I want to get that y value by itself. So I need to move everything else away from the y, right? And remember, think about this is that scale, that balance. So if I do something on one side of the equation, I have to do the same thing on the other. So right now, I could add 9 to both sides, and it's still valid. It won't help me, but it's still valid, as long as I do the same thing on both. But what I want you to do is look at the y, look for the letter you're looking for, and kind of ignore it for a minute. I'm going to get rid of this. So whatever's connected to the y, leave it there. I'm going to get rid of 3x. This is a positive 3x. So I'm going to subtract it. So that goes away. I have negative 5y equals, and I'm going to write it like this, negative 3x plus 10. Order really doesn't matter because we're adding and subtracting, but I'm going to write it like that because we typically write the x first. And here I'm going to add and subtract because I want to get rid of the whole thing. Now I only want to get rid of that negative 5. I want to leave the y there. I want to get rid of that negative 5, so now I'm going to divide, and I'm going to do it over each one of my terms. So over here, it just gets rid of that, so I have y equals. This is a negative over a negative, and if I have two negatives, it's positive. So 3/5 x. 10 divided by negative 5 is negative 2. That's my equation. My slope is positive 3 over 5. And then my y-intercept is negative 2. But my slope is positive 3 over 5. So here's my y. Right? The only thing over here with it is this minus 2. So what I have is y equals 2.5 x plus 1 plus 2. We don't like all the parentheses everywhere. So we're just going to distribute that. We're going to multiply 2.5x plus 2.5, and then I still have that plus 2. So that means y is equal to 2.5x, and 2.5 plus 2 is 4.5. All right. Kind of the same thing here. I'm trying to solve for y, so I need to get rid of anything that's over here with it. That's plus 4. So we're going to subtract 4. This I can't do anything with. I know I have a bunch of negatives and we don't like that, but I can't do anything with it. So that is my answer. This one don't worry about because I can't see it because it's covered up. But what this says is if these are inequalities, if I have 2x plus 3y is greater than, that's a bad example. If I have 2x minus 3y is greater than 5, 2x minus 3y is greater than 5. Do the same thing. I want to solve for y. This is attached, so ignore it. I want to get rid of this. So minus 2x. So I have negative 3y is greater than negative 2x plus 5. Now, right here, I want to keep the y. I want to get rid of this minus 3, so I'm going to divide by negative 3. But as soon as I divide by negative 3, I have to flip that sign over. So instead of being greater than, now it's less than. This is a negative and a negative. And I'm just going to leave that as 5/3. But just keep in mind, if I'm multiplying or dividing by a negative number, I have to flip that inequality over. If I'm dealing with greater than or less than, we're going to flip that sign over. All right, let's see. All right. So what I want you to do is there's 4 pages. 4 pages of examples. So this rate of change and solve for y, there's 4 pages with examples on it. Work through those. Once you have finished this video, there's going to be a key that comes up. You'll be able to see it, so you'll be able to check your answers. I'll kind of walk through those, show you the work on those. And then the next one is going to be linear functions. Thanks.